Good afternoon, everyone. It's great that everyone's still stuck around, and hopefully you'll be able to stay awake long enough for us to finish off this last presentation of the day. My name's Reto Meier. I'm a developer advocate on the Android team based out of the London office, and today I'm presenting with Michael Mahemoff, who is also a developer advocate in the London team. He works on Chrome, HTML5, all those good web type technologies which you've been hearing all about. Today, what we want to do is talk a little bit about the alternatives you have for developing for mobile, whether that's building web-based applications or native. And in this case, when I'm talking native, I'm talking about developing using the SDK rather than native in terms of what Dan Galpin was talking about earlier of NDK, C++ stuff. So it's the standard SDK type development. So the question, should you build mobile apps as HTML5 apps or as native apps? The answer is yes, you absolutely should. So what do I mean by that? It's a little ambiguous. So let's start. I'm going to kick off and talk about why you should build native apps. And really, my whole thinking around this comes down to if you can't think of a way to improve the functionality of a web app by using some of the native SDK features, you're doing it wrong. There are so many features, so many advanced things that you can do, so many improvements you can make to your app using the native SDK libraries that if you can't come up with a way to improve it by using some of these tools, then you're not thinking outside of the box. You're not thinking in terms of how you can really change the way people interact with the data that you have. So what do I mean by that? Well, the first thing is in terms of speed. Anytime you're building something directly for the SDK, it's going to be significantly faster than it would be if you had to build it on HTML5. And the reason for that in Android is quite simple. You're adding an extra layer. If you're having to run through the browser, then you've got an additional framework layer between you and the operating system. And for something like anything which is running on a mobile device, as I mentioned earlier, you've got a really resource-constrained environment. So these small changes in efficiency can have a dramatic impact in how fast your app runs. So in terms of speed, there's the lower you can get, the closer you can get to the underlying operating system, the better off you're going to be. What I think is even more important than the speed of the app itself is the speed of innovation. Now, we've heard a lot about the growth of the web and the fact that HTML5 has, as a platform, the web has already won. And I think in desktop development, that's absolutely true. But what makes mobile a little bit different and a little bit interesting is that there's still a lot of innovation happening in terms of the hardware itself. Now, if you think about a desktop, a laptop, the hardware, it hasn't really changed. It's been pretty much the same for the last 5, almost 10 years. Since the mouse became mainstream and the joystick sort of disappeared, you've got the same sort of setup. You've got a monitor, you've got a keyboard, you've got a mouse. Now, if you look at mobile devices, things are quite different. In 2007, when the iPhone was released, we saw multi-touch for the first time. We saw accelerometers controlling input. We saw voice commands, these sorts of things. And I remember seeing the iPhone, and I was hugely impressed. This was the sorts of things which we'd never seen before. Real innovation in terms of hardware, which was driving entirely new ways to operate within the software, and entirely new kinds of software that can be created. A year later, the G1, the first Android phone, came out, and we saw video. We saw the ability for developers to create applications which use the video stream directly. Same with Compass. They were able to get access to the Compass direction, and they were able to create apps that run in the background. And if you look at some of the apps which came out of this innovation, we've got things like Layer, Wikitude, Eloqua, all of these apps which are able to use all of this information to create augmented reality apps, to create apps which use your location context to provide you information. Now, this is really important because not only did it mean we have a whole slew of new innovative apps, but it actually meant that what we saw later that year was when the next release of the iPhone came out, it too had support for video and Compass. And even now, background apps are supported to at least a degree within iPhone. So we're seeing not only is this hardware rapidly evolving and the software toolkit's evolving as well, but we're seeing the competition in that market making all of this hardware become more broadly available. In 2009, we saw the Bluetooth stack on Android become available, and most importantly, we saw support for multiple screen sizes. So all of a sudden, the smartphone market wasn't just one fixed size. And now we've got tablets, we've got tiny things, we've got Google TV coming. We've got all of this innovation in hardware, and we've got the SDK gives you the ability to be able to keep up with those rapid innovations in hardware. So we're able to create really innovative new things, keeping pace with those hardware innovations. And as mobile manufacturers continue to try and innovate, to continue to try and differentiate their products, they're going to do so by creating new kinds of hardware, incorporating new things. This year, we saw gyroscopes in the iPhone 4. We've seen front-facing cameras in an increasingly large number of devices. Next year, who knows? We already saw just yesterday that Eric Schmidt was showing off near-field communications in the Gingerbread release of Android. So we can see, this constant cycle of innovation, of new hardware, and the only way as developers that we're going to be able to keep pace with that, to be able to access all of these new kinds of hardware, is through using the native SDKs. The thing about anything which is web-based is that it's standards-based. Let's see, I'll jump back here. So it's standards-based. So you need a consensus. You need to have a series of things which people have acknowledged is going to be in a lot of hardware, and it's going to be implemented in much the same way. And so even with the impending hardware standards that we've seen, things like location-based services, microphone input, accelerometers, all of the really cool things which we saw at the keynote this morning, it's still always going to trail. We've had these sorts of things available in the mobile space since the first iPhone. And we're only now starting to get to a point where it's becoming standardized within WebKit. So really, if you want to be able to keep on that cutting edge with these, each of these new innovations that we've seen each year, the only way to do that is by using the SDKs and being able to create products around that. So as well as the new hardware in terms of the sensors and those sorts of things within each device, we're seeing a much broader range of hardware platforms. Tablets, televisions, and what comes after that? Well, at CES earlier this year, we saw cars with head units running Android. We saw picture frames, fridges, washing machines. It's a huge list, and a lot of this stuff doesn't necessarily make a lot of sense. But from a developer perspective, these are just more platforms in which you can create apps. So is it always going to be the same app? Are you going to create the same mobile app and make it work on a fridge? Maybe, maybe not. But maybe there are specific apps which will work specifically for fridges that make a lot of sense. And the same thing for cars. And the key to this is that if you want to be able to take advantage of specific APIs which let you do things like measure the temperature within a fridge or let you control the oven, the only way that that's going to happen in the short term is by using the native SDK. Anything else is going to require that to become standardized, to become commonplace, and for a consensus to build before we're going to be able to build web standards which give you access to the same sorts of things. So right now, this is the kind of hardware that you're able to develop for using native SDKs. You can use video cameras, sensors, multi-touch support, telephony, Bluetooth, microphone. All of this is available today without having to wait for any further standards to be developed. One of the things beyond hardware, which I think is really exciting, is the ability for your apps to be able to pass information between each other. So they're not sandboxed within their own web page, they're sandboxed within each of their apps' installation folders, but with porous borders. So you're able to pass information between apps, you're able to leverage some of the functionality between different apps to enrich and expand each other. So what you're getting is a much richer experience by being able to combine apps so that they work together. And beyond that, you've got the ubiquity. You've got things like home screen widgets, live folders, quick search box, so you can surface your search results from your app to the user on the home screen. Your notifications, background applications that run without having to have any window open or any app running. The ability to replace the native apps on the phone and have that deep integration with things like the contacts. I mean, these sorts of things may eventually become standards in web as well. But that's certainly a reasonably far way off. So will these things converge? Perhaps. But as of right now, if you need to do these sorts of things, if you want to become a first-class citizen on mobile devices, the only way to do that is by creating an app specifically for, using the SDK for Android devices. And background services, as I say, is kind of a major thing there. Cloud-to-device messaging, concurrent apps, things like Spotify, things like Chrome to phone, all of these things, again, are going to require you to have a native app. So, to summarize real quickly, these are the sorts of Android platform features which you can do right now. And as you can see, there's a huge array there, and pretty much all of that, with a couple of exceptions, is only possible using the native SDK. So, when you're sitting down to decide how should you build this app, you've got this killer idea for an app which is going to work on a mobile phone. Should you build it natively? Well, if you're going to be accessing the hardware, particularly anything new, absolutely. Also, if you want to integrate system features, things like contacts, specific things which work only on a particular kind of hardware, then you're going to want to build it natively as well. If you want to interact with other applications, if you need to be really fast, if speed is an issue, and it almost certainly is, then you want to build natively. And similarly, you want your app to be as rich a part of the user experience as you possibly can. Be ubiquitous, have widgets, be more than just a web page. Then you want to build something using the tools which we have available. So that's a brief summary of the case for building native. I'm going to hand over to Mike, and he's going to talk about why you should do exactly the opposite of what I've said.
Thanks, Reto. So yes, the case for the web, or HTML5 as we nowadays seem to call it synonymously with the web. So I want to start off thinking a little bit about form factors. And that's a real computer. That's from when computers were actually computers, and that's not a computer. Now we have things like Google TV, and that starts to blur the distinction. So we can have a TV that has connectivity, it has a real computer-grade device inside it, it allows third parties to write apps for it. Likewise, that's a real phone. Same deal. You can do all these things, third-party apps. We've seen it already working, and we have real computers in our pockets these days. We talked about convergence for a long time. Now we're really living in this age of convergence. And this is a great thing. You know, for users, it means we get to have all these form factors. We can actually fit these devices, these computing, powerful devices, into our lifestyles. We can surf with the laptop sitting on the beach. We can sit on the train and use a tablet. We can walk around with our phones. We can, when we want to do dedicated work, we can indeed use a proper high-end processing computer with all the right hardware sitting there on a desk where it fits and where we can actually do sort of high-end manipulation of data. And we can also use the TV in the living room where it's more of a social environment. So these are good things. These fit into our lives, and it's great that we're now at a point where we actually have them. But for developers, they're kind of a mixed blessing, because we do actually have to do a lot more work to reach all of these different devices. And it's not just these ones I've shown you here. It's a whole lot more. It's thinking about, even for the desktop category, you think about things like laptops, netbooks. Then you come down to phones, you think about smartphones, but most of the world is still using traditional, smaller feature phones, tablets, TVs, and then there's a whole lot more. Reto mentioned some. Watches, cars, fridges, and of course the USB desktop aquarium, that vital device that we should all be thinking about targeting. When we think about the operating systems for each of these, it's not like we can just say, okay, I'm going to do my desktop, so I've just got this one desktop operating system and one programming language I have to deal with. No, you've got Windows, OS X, Linux, you've got lots of different versions of each of those. You've got many more smaller operating systems as well, just to reach that one form factor. Think about mobile. Likewise, you've got many different operating systems. Android is a very important one. Likewise, we've got iOS, BlackBerry, everything else as well, and version numbers of all of those as well to target. So where does this go in the future? We don't know yet. We don't necessarily know what sort of form factors we'll have in the future. We can guess things like cars and the sorts of things that Reto and I have covered, fridges, ovens, maybe they'll be there in 2015 too. We don't really know. We don't really know which operating systems will be dominant. We don't know if it'll be one or it'll be many still. What we do know, because we have that today, and we can be very confident that it will still be there in 2015, is the web. And so if you're thinking about your architecture for today and having something strong that will actually last the distance going into the future, and you want to get a high level of reuse, then you really need to be considering the web and HTML5. This is the phrase you might have seen before, write once, run many. That's the promise of the web. And you can be forgiven for being a little bit skeptical about this phrase. I don't intend it to mean as a magic bullet. I'm not saying that you write one app, the entire app, and you port it to all of those different form factors and operating systems. There still is going to be a level of customization there. but certainly the bulk of your logic, your business logic, and even large parts of your user interface, you now have a platform that is actually running. It's there as browsers, and it's also there as runtime components to be embedded into native apps, being HTML, CSS, and JavaScript, the components of HTML5. So the web actually is, I would argue, a very capable platform for doing the sorts of things we've already seen with smartphone apps, the things that make smartphone apps so popular. If you actually look at the actual capabilities and the fundamental principles, the architecture of the web right from the start dealt with a lot of the things that smartphone apps deal with today. And when I say smartphone apps, of course I mean TV and so on as well. Firstly, when we think about the user interface for the web, where the web started, it started in a research institution. It spread very quickly to companies and universities and just people in their houses, hobbyist hackers and everyone else. And you could never assume just one device. You could never assume one operating system. You could never assume one screen, one form factor. So right from the start, the user interface model of the web, the DOM and HTML, has always had to assume that there'd be many different sizes and different resolutions and so on. And so if you write a bit of HTML, it will nicely stretch across the whole width of the screen. And then there are ways like CSS to customize that, to make it 50% here, 50% there. There's whole books and ideas and patterns for how to actually deal with lots of different resolutions, have the same code base, and actually target all of those different screens at once. You can also go further. If you really want to, you can actually be very specific, and you can use techniques like CSS media queries to actually say, yes, this is exactly how it should be displayed on this particular device when it's running at this resolution and so on, for the devices and the operating systems and so on that you really care about. But for everything else, you get very sensible defaults. In terms of security, the web also has security built into the heart of it. So one of the great things about apps is you can go to an app in the marketplace and you can be confident that when you install this app, it's not going to have access to the low-level hardware. It's not going to have access to store as much as it wants. It's not going to be able to communicate with all the other apps and read your data from all the other apps unless you give it the consent. And the same has always been true of the web. The web would not have worked if you could go to a new website and suddenly that website's sitting there reading your hard drive. So the web has always had a concept of keeping sites in this tight little sandbox. But just like we've seen with smartphone apps, we do actually have the ability to punch holes in that wall, and where the user gives consent or where the applications agree with each other, they can actually cross the boundary as well. That's something the web hasn't had until recently, but now we do have a lot of ways for web apps to be able to communicate with each other as long as there's the right consent model there. So we've got techniques like OAuth. So you've seen there's 1,000,001 Twitter apps. They do all sorts of things that Twitter.com would never want to do themselves. Things like show me my first tweet or show me your recommendations for people who make similar tweets like me or someone. All those things require some permission from you, and they also require permission from Twitter, and that's done by this modern protocol of OAuth. Similarly, you've got something like cross-origin resource sharing, which lets a browser make calls to other domains other than the ones that actually served the website. Cross-document messaging, similarly. You also have permissioning for extra functionality as well. So again, the web traditionally didn't allow this sort of thing, but now it does. It does allow you to do things like geolocation, to detect device orientation, to detect if the user's gone away from their computer. Those are the sorts of things that give the web and give HTML5 a much richer capability and let us do the kinds of programs that we can do in native apps. And that's great for when we write HTML5 apps that run on mobiles and tablets. It's also great for just taking those concepts and bringing them back to the desktop. There's no reason why when you're sitting there with a laptop or a PC, the computer should also, in that case, know where you are as well. But of course, it comes down to a permissioning model there too. And so what we're saying now is, yes, the web can actually access these extra capabilities, but we have to make sure that the user gives consent to it, because you can go and surf 1,000,001 websites. That's the real power of the web. You don't have to install things. You can just visit a website and try it out, and it could be a very rich web app. It doesn't require installation. So you can do that, but we want to make sure that you know what your capabilities you're giving to each of these apps. So that's the theory of it, the fundamental architecture of the web. What can we do in practice? What are these capabilities we can get hold of? And it's worth saying that all of this is actually available today. So the sorts of things I'm talking about, they are getting better. They'll be hopefully even better next year. But right now we can do this. And this is actually an example of this. This here is chalk.37signals.com. It was created by 37 Signals about a week ago. It uses the HTML5 canvas to do a Blackboard style app, and it works on the iPad. It only works on the iPad because they did the whole app in 3 days, but it shows that HTML5 is ready today, and you don't have to wait for all of the specs to evolve, because they are still evolving. You can actually use it in your own apps right now. It's also ready from a performance point of view, so we've had massive speed increases. We'll probably continue to see them. But you can see one of the cool things about the web is you can actually go back and download a very old version of a great browser, Firefox. So I tried this out. I downloaded Firefox 0.8 from 2004. And you can see like the changes here from 1800 milliseconds right down to 10 milliseconds with a recent version of Chrome. For JavaScript, the actual core processing. As far as graphics and rendering, just a random test I chose, down from 111 milliseconds to 2 milliseconds. So there have been massive speed improvements because there was just so much fat there that was actually waiting to be optimized that no one really cared much about. Now they do, and now there's continuous research to make the web even faster. We're going to see even more with hardware acceleration in the future. So to show you a few of the demos and the sorts of capabilities we've got, I've got a few demos here, hopefully lined up, so I don't have to rely too much on the Wi-Fi. Where are we? So firstly, I want to show you a game. We ran a game jam a little while ago, so that we could actually get developers in a room making like a hackathon event where they could make games. And this was actually a game some folks put together in around 24 hours. It was just over 24 hours. 3 people created this. They've gone on, but the basic game was actually there straight away. So here we go. So, whoa, I think I've just about died. Hopefully the Wi-Fi is still working. There we go. So I have to blast them with one hand, but I'm just going to run away from this guy now. All right, one more try. I'll take the peaceful approach here. So, and it's also got collision detection. So if you actually go up right towards those walls there, these guys will actually, you can see there, they can't actually blast beyond the walls. And now we're just about doomed. But it's still going on, and the coolest thing about this game is the 3D effect. And they did this effect too within the time that 2-day hackathon. So it's pretty cool. And this is actually canvas. This is a 2D canvas. It gives you a graphics element that you can basically take. You get all the pixels. You can paint them however you like. Standard sort of canvas element you get in a lot of different platforms. And that's why we're seeing so many games now, because it just wasn't possible to do this a couple of years ago. And it's now really becoming standard. Even Internet Explorer 9 has added it. And what was interesting about this, when we talk about the write once, run many, is they developed the whole thing while they were doing the hackathon. They actually developed it all using Chrome and just their laptops. But then we had Galaxy Tab there and an iPad there, and we just ran it, and it ran straight away. It worked fine. Now, they hadn't optimized it for that, so there were certainly performance issues. Those devices don't do hardware acceleration yet. But if they wanted to optimize it and start handling touch events, they could with the same 3D logic and the same gameplay and content. They would be able to reuse all of that. Another game, this is actually a game engine, so we're starting to see people actually develop game engine. This is Effect Games. This is actually a game engine that lets you write games, and this is an example of a game that they've put together. With sound as well, but I can't show you that now, so let me just die. So, and then you've got all this stuff too. So you've got these capabilities as well. You've got, pause and music control and volume and everything. All of that's built into the game engine. There was another game engine recently that actually got sold to Zynga, so it was the first example of an HTML5 game engine being acquired. Where are we? Oops. No, not that. Right, so that's Canvas. The next thing to say is CSS, right? Because the web is full of content. The web is about information and just representing information in interesting different ways. And so while Canvas games and graphics demos are cool, the real fundamental thing is how can we represent all of these forms and e-commerce sites and just the typical sort of things you see on the web. We can do that much better now with the web as well. So there's, again, a couple of demos here. If I go for this one, well, you can Google for Lost World Fairs and find this demo. What you're seeing there is actually just plain text. It's just being represented in interesting different ways. And all of this is selectable, so it's not actually images. It's custom fonts that we're able to download using CSS, CSS3. Also, we've got the idea of transforms as well. So when we think about transforms, where are we? There we go. So all of this is plain text as well. Selectable text. We've just moved it around in 3D space with just a few lines of code to say how we want to move it around, so we can rotate, scale, and so on. And real button. And that actually is a real video element. Again, if the Wi-Fi is working, we can actually play this too. So it's just someone's taken a video element and just shifted it around in space. Then we can look at the input side of the user interface as well. That's just as important, and we're getting a lot of inspiration here from things that people have been doing in the world of smartphones and tablets. So we can also do geolocation. So an example here. So if you actually look on this site, lionsnearyou.com, my favorite site, you can find the closest lion. Unfortunately, it's not too close, which either means there aren't many lions around here or you guys need to update their database. But it's detected the location, and I've given it the permission to do that, and that's how it's known about location. We can also do orientation as well. So this is a demo. It's the first game, to my knowledge, to use orientation in HTML5. Unfortunately, it only works on a MacBook, and it doesn't yet work on the kinds of devices we'd really like to work on, obviously, tablets and smartphones, but it is there. On tablets and smartphones with HTML5, you can at least detect, typically, depending on the device, but you can detect orientation, so you can detect portrait versus landscape. That works with Gmail, so if you try Gmail on iPad, you can actually see that in action. Having these sorts of things let us do these things on native devices, so we can actually, in the future, we'll be able to do orientation the same way a native app can do on a mobile or a tablet, but it also has applications on other devices as well. And we can do speech detection, of course, with HTML5. It's starting to be a big thing, still very early days. And we can also do idle detection. So we can actually say, if the user's walked away from their computer, we can tell someone during a chat or a multiplayer game. In the future, it's very likely we're going to have device APIs for camera and microphone. I think this is great because the web technology is extremely easy to hack with. I've been to many hackathons and I've seen people come up with great ideas, very unusual ideas, things that people might not have ever thought of before, just in a single day, because all you need to create for the web, to try it out, is a browser and a text editor, and then you just go away and you can start hacking on ideas. So when you've got something that's that simple to get started, and you've also got all the capabilities to start using the camera and the mic. I would love to write programs, that do things with camera and mic and orientation and so on. But up till now, if I wanted to do it in a language like Ruby, which I use a lot of as well, I would have to do a lot of research, to find out how it works on my particular device and so on. But with the web, you've got a very standard way of doing it that will work just on any browser straight away. So when we think about things that aren't just user interface. So I've talked about output and input, but also there's a lot of other aspects to HTML5 as well in terms of just the kind of functionality you can access. And one of them is networking. So we've traditionally had links and forms that would actually be the only way we could interact with the rest of the world, and you'd have to wait for a full page refresh, wait 10 seconds until you can actually do something again. A few years ago, there was this great discovery of XML HTTP request and the so-called AJAX revolution. We discovered that there are ways to actually let the user keep on clicking and typing and playing around with what's in the browser, but at the same time, in parallel, we could actually upload new information. So we could do things like save the document the user's working on, and we could also download new information, get the latest news and get chat information and so on. What we now can do with HTML5 is we're going even further with that. We can do cross-domain access, so we don't have to pipe everything through the server to get to all the rest of the world. We can actually go directly from the browser to any different server as long as that server gives the right permission for it. We also have ways of doing two-way streaming. So if we want to do fast, secure, multiplayer games and chat, we need to use these newer APIs, WebSocket, server-sent events. They're only just starting to come out. We've traditionally been able to do hacks and workarounds, which is the sorts of things you see with Gmail and Facebook when you do have chat in the browser. It is possible, but it's been very messy up till now. With something like WebSocket, we've got a dedicated API to do it, so it's going to be easier and more powerful. We also have much better capabilities for doing offline apps. So again, when we think about native apps, one of the great differentiators there is that users can install an app and it works when they're not connected to the computer. That's starting to change too with the web. We can use application caching, what's called the idea of an HTML cache manifest. It's a very simple protocol that basically says if you've got a cache manifest that's linked from the HTML, it just has to list all of the assets of your app sitting on the server somewhere. It lists your assets, and that will cause your browser to keep them in the browser, on the device, on the client, and they will work the next time the user visits your website, even if the user isn't actually online. So not only does it work, does it allow the user to work when they're offline, it also is faster as well. It means your entire app doesn't have to load up every time the user wants to visit your site and actually wait for the whole thing to download. As well as caching the application, we can also cache the data, or we can keep the data locally as well. So any data that the user's generating, or any new information that's coming from the web that the user wants to mark and retain for later on, we can also use various of these APIs to actually store that data as well. So there's that offline aspect, but there's also the idea of installing these apps too. So we can do that with, for instance, in Android, you've got your home screen, and you want to see all the icons of all the apps you've actually installed. We can start to do that on the web too. We've got few different ways to do it. Firstly, we've got techniques. The simplest way is we roll our own. So if you know how to do Android programming already, you can use a web view component, and you can do all your HTML5 programming inside the web view, and you just put that inside your app. But what you can also do is you can use these frameworks like PhoneGap and Titanium, and they will do the work for you. And not only will they do the work for you, but they'll also expose native APIs, things that aren't yet there with HTML5, like accessing the camera, accessing large amounts of data, device orientation that doesn't yet work in most, or doesn't work in any mobile devices yet. All of those sorts of things you can also access using PhoneGap. It will actually expose them in a way that you can program to them using JavaScript. And that's in the mobile space. In the desktop space, you've got Chrome Web Store that we're launching later this year. And the idea with the Chrome Web Store is it serves as a directory of all the apps. So if you're looking for a photo editor or something like that, you can actually find a web-based version of that will run on that desktop, laptop form factor. And you can also go ahead and install it as well. And there's a monetization model there too. So people who write great web apps, they can be rewarded for it by putting it in the store and asking the users to install it, and they can actually get paid for that. So I've focused mostly on compatibility and tried to say how the web's close to parity with all these native features. But a few other great things I want to highlight about the web. Firstly, the web is based on open standards. So if a browser manufacturer has an idea, they've got a need to actually do something, they can go out and try it out, and developers can give them feedback on how it works, and it all starts to feed back into a general standard that gets documented, other browsers agree on it, and you end up, as a developer, not having to rely on any one party. You're not you're not waiting for them to do something. You can actually get, if you've got the demand there. A lot of this is based on open source as well, so you can provide your own implementations of these things. And so it's a nice strategy if you don't really want to be locked into any one party, and it's also something that tends to evolve things quite quickly as well, because you have all these different groups working on the same standard, so you have people sharing the same techniques no matter which platform they're actually writing against. Similarly, it's easy to dive into web technologies. Like I mentioned, any laptop has a text editor on it and a browser, and that's really all you need to get started and write a great web app. There's also much better tool and library support today than there was a few years ago. So we have tools like Chrome, for instance, has the developer tools built right into it, where you've got an integrated debugging and profiling system. Likewise, many of you may be familiar with Firebug, which is another great debugging tool that works on Firefox, and there are many more for the other browsers coming out too. There's also library support there, so libraries like jQuery you may have heard of, they make development so much easier. So between having the debugging tools and the libraries, development with JavaScript and HTML5 is exponentially more productive today than it was, say, 5 years ago. And there's also a very diverse community because of all the openness here. So an example I gave at that Game Jam conference is the way that game developers actually benefit from all these other developers in other areas. Because HTML5 is very open, you don't tend to get clusters of a certain kind of industry working in HTML5. You get every kind of industry and research institutions and hackers at home and so on. And all of them are sharing information. And so in the case of games, when a bank does some research and creates libraries and creates knowledge about how to actually do fast networking so their traders can get information faster, a game developer will benefit from all that information about how to do faster networking. Likewise, visualization companies, when they do research on how to actually do better visualization, when they develop tools and libraries for SVG and Canvas, also benefits game developers. So there's a lot of cross-fertilization of ideas and technologies in HTML5. So I'll leave it there. I'm going to hand back to Reto, and I just want to talk a little bit more, or just want to point out that if you want to find out more about HTML5, you can go to these sites. HTML5rocks.com is a site where we've got samples and tutorials and so on. You can learn more about how to actually code and get started with HTML5, and also for advanced developers. And Chrome Experiments is another place where you can find out some of the very bleeding edge things people are doing with HTML5. Reto.
Thanks, Mike. So, where does that leave us? So we've pitched why you should build native, and Mike's explained why you should actually build with HTML5. And there's a lot of reasons why either may be the right solution for you, which is why fundamentally I think which technology should you use is kind of the wrong question. So what's the right question? What's the right question, or what's the right answer? And I think fundamentally we have an opportunity here where you can make the best out of both of these excellent opportunities. We're talking about being able to harness the ability of web apps who have near universal coverage, this ability to deploy once, update instantly, and also have native apps which have that deep hardware integration, that system integration, and the rich ability to be able to take advantage of the hardware innovation. So what we're really saying is that for a lot of cases, what you should be thinking about is doing both. It seems like a harsh suggestion. We're basically saying do twice as much work. But I think it really depends on where you're coming from. If you've already got a service, if you've already got a web page, a website, which is providing a service for your users, it makes sense to optimize that for the for a mobile web experience. You've already got the skills in-house. You've already got all of the server-side infrastructure in place. It shouldn't be a huge amount of additional work to optimize that for the mobile platform. At the same time, you can then take advantage of some of the native tools to be able to improve on what that app delivers, to create a specialized, optimized experience specifically for particular hardware on particular platforms, which means building an Android app which does take advantage of the microphone, of the camera, of location-based services, of near-field communications, of all of the hardware and platform-specific features which you have. So when it comes to that, you really need to figure out, what do you need to do? What are you trying to achieve? If you're building something new from scratch rather than from a pre-existing website, then you really need to spend some time and say, well, do I need the hardware access? Does it need to be super fast? Do I need to have that rich system integration? Now, I would argue that any good mobile app these days, you should be able to find ways to use these features to improve the app that you have. But there will be some circumstances where that's not necessarily the case. And in those circumstances, you may be better off investing your resources building a website, something which is going to give you access to every single modern mobile platform rather than just one individual. So I'm going to ask Mike to give us some additional points, I suppose, on what you may consider.
Yes, I'm just going to finish off today's session by giving you a few practical points about how you might think about doing the sorts of things Reto was talking about there, to combine the two aspects, to basically put HTML5 into your native apps. And firstly, it's true that most platforms already have support for HTML5. So they have a browser, and they also have typically modern browsers. If you look at Android and Apple, for instance, the browsers they already have have got many of the features of HTML5 built into them. They also have a web view component that your native apps can take advantage of. You can embed this web view inside your native apps. And so you can imagine using the web view in a way that's not all or none, that in a way that mixes a little bit of the web view with something that's really fundamentally a native app. So something like if you're doing a book reader, do the catalog in HTML5. It's very information-based. It's fairly commodity. It's probably not the most high priority thing for your book reader. And if you want to have a really slick user interface and you prefer to do that in native, then do that and make that different for all of the different devices. But you get to reuse the entire catalog component across all of the devices. Similarly, a game, you can imagine a high score area, community area where people can find their friends. All of those sorts of things you could do in HTML5. The actual game, the underlying content of the game and the gameplay, where you might prefer to use the hardware, you might prefer to use native capabilities of the device, you might do that with the actual native SDK. The other approach, of course, is to do an entire HTML5 app, and people are starting to do this sort of thing already. This is where you basically take the entire HTML5 app and you wrap it up as a native app, and that's basically users probably don't even know if you've done it right that they're using an HTML5 app. They just feel like it's something they can buy from the marketplace, whatever marketplace we're talking about, or install it some other way. Excuse me. And they can install it. It works when they're offline, so they wouldn't really even care or know that they're using the web. I mentioned PhoneGap as one technology to facilitate this sort of thing. You can see some examples of what people are doing with PhoneGap, phonegap.com/apps. What's really exciting, in the past couple of weeks, there are a couple of new products that have been announced. Excuse me. Firstly, there's build.phonegap.com, and secondly, there's Apparatio. Both of those are built on top of PhoneGap, and what they do is they actually work in the cloud. So you can actually upload a zip file of your HTML5 app, and they will actually then give you an Android app or a BlackBerry app, or in the case of Apparatio, it also will handle iOS as well. So you don't even have to go to the effort, which you do right now with something like PhoneGap, of actually installing PhoneGap on your device, installing Java, installing the Android SDK if you want to build Android, or whatever other SDK if you want to build for other devices. Right now, that's how PhoneGap works. most HTML5 developers, if they're doing pure HTML5, they don't want to know about any of that. They just want to have something that just gives them these native apps already automatically, and they can just do their development inside the browser. So this is starting to happen. You can even point these services to your GitHub, and the way they work is they'll just go in and look at your GitHub, and they'll output an Android APK or whatever else. And even more exciting is what could happen in the future. You can imagine where all this is going is they will automate the workflow of submitting your app to the marketplace as well. So you would just do your normal development in the web with HTML5. You keep committing it to a GitHub repository, and then you click a button and suddenly it's sitting there on 10 or 20 markets. You know, that's the kind of vision that these people are hopefully going to be working towards. And also I'd mentioned Accelerated Titanium. They've both got strengths and weaknesses and both worth checking out. Also thinking about when you do your HTML5 apps, make sure that it does actually work offline, the same way you'd expect a native app to work offline. So take advantage of those offline technologies. Don't just point your app to the server, actually look at packaging your app up so that the HTML, the CSS and so on actually lives inside the client device, because that's one of the reasons why people complain about when people are using HTML5 for native apps is they're just opening up a view into a remote server, and of course that's going to be slow and you may as well have just used the browser. But in this case, when you actually package all of the logic up and run it locally, it will actually feel a lot faster. And if you can't or you don't want to do that, at least use application cache to actually make sure that logic is actually cached locally as well. Also think about prioritizing your platform. So you can't reach all these 1,000,001 platforms. Think about the ones that are the most high priority and really customize them. So customize them by using native features and also customize the HTML5 as well. You use techniques like CSS media queries so that you're targeting specific devices, and also use JavaScript feature detection, because none of this is a magic bullet. The devices do vary quite widely in terms of which particular HTML5 features are supported. Some might support SVG, some might support orientation. It will be a little bit different, so be prepared to check if the device that you're actually running inside actually supports that, and be prepared to degrade. The web has a long history of what's called graceful degradation and progressive enhancement, so that it can target a whole range of devices without having to throw things out and start creating a new app for another device. And also look at native styling. There are a lot of libraries that do this, that actually let you build user interfaces that give a good impression of being native but are still being constructed using HTML5. So we've got some session feedback link there for you, and if you've got any feedback, please let us know via Twitter. I think we've got a little bit of time for questions. Yeah, what's the time now? Yeah. All right, let's do just a couple of questions. People got questions? Oh yeah, question on the back there. Right. So the question is, what do we think about Flash, and specifically from an Android developer perspective, what do we think about Flash?
So what do we think about Flash? We think Flash is great. It's a technology which has really helped move the web forward, and there's a lot of people out there who've created some really great content. From an Android perspective, it's important to us to try and make the platform as open as possible, and to try and make the web browsing experience as rich as possible. So we fully support Flash on Android, and as far as application development goes, we wouldn't suggest that you not use Flash. On the other hand, it's similar in terms of the limitations. It's similar to what I was talking about earlier versus HTML5. Only now you've got yet another layer of abstraction above. So you've got Flash running within a browser, running on top of the virtual machine, running on top of the operating system. So I think there's going to be some limitations there in terms of the hardware access, and also some implications in terms of performance. And I think performance in particular is a big consideration when you're working with mobile devices. So if you do intend to develop for Flash, be aware that sort of not every mobile device is going to work with it, and that it is going to have some significant performance implications as well. Any other questions? I don't think so. Okay, so there seems to be a lot of people streaming in. We're actually going to do the closing remarks are going to happen in this room. So those of you who are here, you can stay seated, and we'll let everyone else file in. So thank you all very much.
Thank you.